Okay, so we're gonna go over this question. As you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position shown in the figure below. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes 3 seconds to reach the top, 43 feet above the ground, and that the wheel makes a revolution once every 24 seconds. The diameter of the wheel is 40 feet. So now we have to solve the questions from A to F. So let's start by putting down what we already know. We already know the period is going to be 24 seconds because as you see here, it makes a full revolution every 24 seconds. Now, what else do we know? We know that the Ferris wheel that we're working with, let me go closer. This Ferris wheel, it has a diameter of 40 feet. We start at this point, and then after 3 seconds, after 3 seconds, we're at this point, its highest point, and from its highest point to the ground, it's 43 feet. 43 feet is not D. D is where we originally started. We don't know what D is, but we know that the distance from here to here will be 3 feet because 43 feet minus 40, that's just 3 feet. So it's just 3 feet. So the entire merry-go-round is 3 feet above the ground. So let's start by sketching this function. Okay, so let this be the t-axis. So when it's at 0, it's originally at a distance of d. We don't know what d is, but we'll just go with that. It's originally at a distance of d. When it hits a time of 3 seconds, this function starts increasing upwards until it hits the maximum height, which is 43 feet. We also, since we know that the merry-go-round is above 3 feet, we know that it will never go below it, okay? Because the merry-go-round is confined to being above 3 feet. So we can do this. So let's put this here. Our function will never go below this line, ever, okay? So as time continues, since we're at our maximum height, we will eventually start going down until we hit our bottom height, which is 3 feet. Then after that, we will start going back up again, and then going back down again. And this will continue happening for an indeterminate amount of time. Now, so we already solved part A, so that's good. What is part B as? What is the lowest you go as the Ferris wheel turns? Well, these points are the lowest, and we know that's 3 feet. So the lowest we go is 3 feet, which makes sense because our lowest will be here, and that's just 3 feet above the ground. So for part B, this is just 3 feet. Now, C asks, why is it reasonable for your answer in part B to be greater than 0? Again, it makes sense because the merry-go-round is, the Ferris wheel, not merry-go-round. The Ferris wheel is 3 feet above the ground. So that's the reason why it's not 0. Now, part D asks, find an equation for the sinusoid. So we can work with these two equations. A sine b x plus c plus d, and a cos b x plus c plus d. So if you can choose one of these to work with, I'm going to choose cosine because for me, this function seems to more resemble like a cosine function, so it seems the best for me to work with. So we're going to just ignore the sine one and just work entirely with the cosine one. Okay. 23 is just how high the white line is, the white dotted line is from the t-axis. So amplitude is just 20. Now, what will b be? We know the formula for period is 2 pi over b equals t. We know t was 24 seconds. So now we can just rearrange and solve for b. So b is pi over 12. So we can replace that here. We'll solve for c later, okay? Because c may be the hardest, trickiest bit to find. So what will d be? D is pretty much the distance from the center line the white centered line to the t-axis, and we actually solved that out before. Remember, it was just 23 we got. The white dotted line is 23 feet from the t-axis, so D is 23 feet. Okay, now we just have to find C, which may be the trickiest bit. So let's start by erasing everything here except for our function. Okay, let's start by continuing this graph back here as well. And let's start by drawing a proper cosine function. So we know cosine will start from here, start gradually decreasing, then increasing, and then decreasing and increasing. So we have to find like what phase shift does the blue line need to move to match the red line. So we know that this point is 3 seconds. So we have to somehow force the blue line to shift to the right by 3 seconds. So that's it. We have to shift our function to the right by 3 seconds. And if it's to the right, then that means it's going to be a negative. So it's going to be -3. C is -3. And this is our function. So that's for part C. Now, part ES, predict your height above the ground when you have been riding it for 4 and 1 plus 1/3 seconds. Okay, so let's have this function f of x equals this whole thing. Recall the x-axis is the t-axis, so x is our time. So we want to find our height, so that means f of x is our height. So we have f of x equals 20 cos pi over 12. That's just 4.333 because it's 4 plus 1 over 3, which is 4.333. Minus 3 plus 23. Okay? Okay, so what will f of x be? So you just use your calculator for this part. And make sure you're in radian mode. Okay, so I got 41.79 feet. So at a time of 4.333 seconds, this is our height. Now, the part F asks, find the 3 times you're 18 feet above the ground. Okay. So what does that part mean? So let me just quickly erase all of this. So let me erase the blue line. So let's say this is 18 feet. Okay? We have to find all 3 points when what was it called? Ferris wheel is 18 feet from the ground. So at this point, and this point, it's 18 feet from the ground. So we have to find the time at these 3 points. Okay? So T1 is actually really easy to find. We have f of x. We just set that to be 18. And x is our time. So we have to solve for x. Okay, so cos pi over 12 times x minus 3, that's all equal to minus 1 over 4. We need to first find the amplitude, okay? So the amplitude is from the maximum, the highest point to the center of the function, or from the lowest point to the center of the function. So we need to find what this will be. So let's start by combining 43 plus 3, because then we'll get this whole distance. So 43 plus 3, that is equal to 46. Now let's divide by 2. 46 divided by 2, that's 23. So the dotted line, it'll be 23. Okay? But 23 is not our amplitude. Now we have to find the difference between 43 and 23. So if we have 43 and we subtract 23, we get 20. So our amplitude is actually 20. Okay? So we just take cos inverse of minus 1 over 4 and set that equal to pi over 12 x minus 3. So cos inverse of that of 0.2 minus 0.25, that's just 1.823, and that's equal to pi over 12 x minus 3. Now let's just solve for x. So times both sides by 12. So these and this cancel out. So we have 21.88 equals pi x minus 3. Divide both sides by pi. This and this cancels out. So we have 6.965 equals x minus 3. And add both 3 to both sides. And we get, so that means x will be equal to 9.96 seconds. So that's what our first t will be, okay? So this is 9.965 seconds. Now, t2 is going to be the hardest to find, but we can find t3. Notice this thing. From here to here, this is just one period because it goes from here to back here again. This is one oscillation, and one period was 24 seconds. So we can just add 24 seconds to here. So 9.65 plus 24, that's 33.965 plus 33.965. Now, T2 is going to be the hardest, but we're going to use this graph to help us out. All right, so let's start by starting from here. So we know this was 3 seconds, so that's good. What else do we know? We know the time here. Okay, so we know from here to here, this will increase by 24 seconds, okay? Because that's just one period. So the time here we know is going to be 3 plus 24. So here it will be 27. That means the time here will be half of 24. So 3 will increase by half of 24, which is just 12. So here it will be 15 seconds, all right? So we're getting really close to solving this. But notice here, this. The difference between here and here is the same between the difference between here and here. So let's do 15 minus 9.965, which is 5.035. So the difference between here is 5.035, and that's the difference between here as well. So we just add 15. We do 15 plus 5.035 to get this point, which gives us 20.03. So that means, 15 plus 5.035 is 20.035. So that's what T2 is equal to, 20.035. And that's your final answer.